all over.
Basic Say it again.
Do we have to memorize? Is this gonna come on the calculator on the test?
The AP test?
Yeah.
I'd have to look back over past tests. I don't. If it does,
Yeah, you do. It's like the whole, and that's the only exercise. Thursdays, not this year. I have too many. Wednesdays. But there is.
I know there's tungsten in the lights.
And you
Good.
can just share
I think so.
it.
I just don't know like
High five. High five. High five.
Although, technically now,
But if you do really well, it's good.
it is actually not the same.
And there's a sun test today.
okay, let's give it a go. True story. True story. At 10 o'clock, Mr. Hughes furnace went out. The temperature in the house was 71. The reason it was so warm is they had two little babies in the house, like 6 months or less than that, and 2 years at the time. So they kept their house, reasonably warm. Temperature outside was 0. By 1, the house dropped to 62. Question is, what was the temperature at 5 a.m. in the morning? So you have to establish these things. T sub naught, N is the initial temperature, which is 71. The surrounding temperature is 0, and it dropped to 62 degrees, and it took 3 hours. That now allows you to calculate the K that you're going to need to use that equation to eventually solve for the temperature at 5 a.m. So,
Is there parentheses around that?
there should be parentheses, sorry. So we go 62 minus 0 equals 71 minus 0, e to the negative k times 3. And of course, what do you do first? Divide before you take natural log. It's easy to start taking the natural log right away, but make sure you divide. And now it's natural log. And then, of course, natural log is 1. And so I get k to be roughly good. Any questions on that?
My case was.
And then you go back and start over. We now know what k is. What's the initial temperature? It depends on when you want to start. Doesn't matter.
70.
If you want to start at
71.
71, okay. The surrounding temperature is 0. The temperature at the end is the unknown, and the time is 7 hours. Okay? And then you just plug that all in. T minus 71, no, T minus 0. So 71 minus 0, e to the negative 0.04518 times 7. And what did you get? How much?
749.
749. That's what I got. Go to three.
That's what I had written down.
Go to 3 decimal places on the AP test. They want you to go. So if it was, is that what you had?
Yeah, that's what I had written down.
Okay. And I'd leave that. Don't go to 7.5 because then they'll take point off on the AP test.
Would they accept if you 51.743.
51 point what?
743. It's really close, it's just depending on where you.
Yeah, it depends on what you choose here or whatever.
Yeah. Because I went 1 decimal place shorter for the.
Okay. Where, up here?
Yeah,
Yeah, you went to there?
I went,
Or to 2?
to 2.
My suggestion is carry this stuff out as far as you can.
Really close.
Nah, you might lose a point.
Really?
Yeah,
Because I didn't.
because you rounded too soon. The safest thing is to keep K equal to that.
Okay.
Because what happens with exponents when you change the exponent just a tiny bit? It changes your answer quite a bit. So the safest thing is to do that.
Yeah.
Okay. Now, real life problem is the house temperature in his house was only 59 degrees. So where did we go wrong? Well, it turns out that they didn't live in a house, they lived in a townhouse. And so what's different?
You've got people who are
You got people surrounding you on each side, so the 0 degrees was only on the front and back. The sides were the temperature of the surrounding townhouses, so the problem, was a little off that way. So it was a good discussion point on why your answer was quite a bit off. Because had that house been considered 0 degrees all the way around, then it would have been pretty close to the 51 degrees. These little babies would have gotten cold.
So what do you do with little babies?
Well, you couldn't get it fixed, you get in your car and turn the car on or something, I don't know. Okay, now, I am really excited and pleased that we're having such success in winter sports and the hockey team is going. And I'm assuming there's going to be a few of you that are going to be going to watch? Okay, that's pretty good, okay. The thing is, we need to keep moving along, so, there won't be any tests or anything tomorrow, but the schedule is 10-3 to 10-2 today, second half of that, 10-3 those 2 days. So, if you're going to be back Friday, you can get the notes. If you're going to be gone both days, I can get you the notes for those 2 days. And then we're going to do 10-4, 10-5, 10-6, review. Oops, there's a quiz here.
Whoa, keep
10-1 to 10-3. And a review, test,
There's a test in fifth hour.
10. So, there's lots of time to catch up on that.
Start.
Good start.
Try it.
Yeah, and then we'll be doing sequence and series, which is a long chapter, and then review.
Like that long test.
At
Me
least.
neither. High five.
Alright. Last Friday we started. Last Friday we started vectors, and the whole point of this section is just kind of introduce vectors. Then the next section will be the derivative and integration of the vectors. So right now we're just kind of working with vectors. So today's topic is to take two vectors. We'll call this vector v and vector u, and find out what the angle is that is between them. And I could just give you the formula, but actually I can give you the formula. All right, I will. The angle is the inverse cosine of u1 v1 plus U2 V2 divided by the magnitude of U and the magnitude of V. So that's the formula for the angle. But now, we're going to derive it, two reasons. One, I think you guys need to see how it comes, but every step of the way is kind of a review of topics that you should know, and it's kind of a good way of reviewing, and then also coming up with the formula. So, this side here is vector W. And we're going to define vector U has two components, an x component and a y component. We'll call it U1 and U2. Vector V is defined by V1 and V2. So let's just kind of review how you define a vector. What's W? W is obtained, remember W is this vector. This vector can be sitting any place as long as it's the same size and pointing in the same direction. So what we're going to do is we're going to take vector U, and then instead of adding U or V to it, we're going to make V go in the other direction. So this is U, and then we're going to make a negative V, and then the result gives you W. You with me on that? W is obtained by taking U, and then instead of adding V to it, we're going to subtract V, and it produces a vector W. Does that make sense? So W is the vector U minus the vector V. Because in order to add two W's, you have to add tip to tail and tip to tail. And here we have both the tips at the beginning. Alright? You okay with that? So, what are the components of W? If this is U1, U2, and this is V1, V2, W is U1 minus V1, comma, U2 minus V2. So those would be the components of W. Now, we're interested in angle theta, and you can get angle theta by using the law of cosines. And remember the law of cosines? If we want to figure out angle A was b squared plus c squared minus 2bc minus, or times cosine of A equals a squared. So it was a squared equals b squared plus c squared minus 2bc cosine of angle A. That's the law of cosines. So now we're going to apply that to this. W is the side opposite theta. W is the vector. How do we represent its length? By its magnitude. And so its magnitude is represented by two bars. And we do what with the magnitude? We square it. And it's going to equal this side squared, which would be the magnitude of U squared, plus this side squared, which is the magnitude of V squared, minus 2 times BC, minus 2 times the length of each of those sides. So 2 times U times V times the cosine of the angle. Okay? Now, let's do a refresher. What was magnitude again? Let's do the magnitude of U. That's the easiest one. The magnitude of U is was Pythagorean's theorem. Remember, to find the magnitude of a vector. This is the u1, this is the u2 that produces u1, u2 vector up here. So the magnitude, the length there is u squared plus u1 squared plus u2 squared square root. So it's u1 squared plus u2 squared. Okay? And, of course, the magnitude of v is the square root of v1 squared plus v2 squared. And what's the magnitude of w? It's the square root of u1 minus v1 squared. Plus u2 minus v.